Hello students, hello students. Myself Mukesh Sikar, Assistant Professor, School of Agriculture, ITM University, Gwalior. So today I am going to deliver my lecture on the topic that is differentiation by substitution. Okay. So in this chapter we will discuss the differentiation by substitution technique. So this is the topic of unit number 3, and this is the lecture number 12 of the subject elementary mathematics, whose code is state 111. Now in today's lecture we will discuss the, the outlines of today's lectures are differentiation by substitution, chain rule, subsequential method, numerical problem on chain rule, numerical problem on subsequential method, assignment, learning outcome, and references. So firstly we will see what is differentiation by substitution. So we need uh, we need to adopt a number of methods for the differentiation of many functions, taking the help of standard deviation, standard derivatives in the intermediate steps. The differentiation by substitution is basically done either by differentiation by substitution, chain rule, or by differentiation by substitution equation. The basic concept in both the cases are same, namely use of chain rule. How can we use chain rule in differentiation by substitution method? So in this method, suppose we have given y is equal to fx, that is a function that is function of x. Okay, so in that case we assume this function fx as gu, where u is a function of x, then f dash x means, so that can be solved by using this formula that f dash x is equal to g dash u into h dash x. So this formula is simplified, and you have to remember this formula that if you have given y is equal to fx, then use this simple formula, that is dy by dx is equal to dy by du into du upon dx. So the chain continues in the same pattern for as many substitutions as present in the equation. That is, if y is equal to fx is composed of number of functions like u1, u2, u3 and up to un, then you can simply use this formula to differentiate this function. So dy by dx, that is equal to dy by du1 into du1 upon du2 into du2 upon du3 dash 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 dun upon dx. So you can use this formula to differentiate this long function. Now, in case of differentiation by substitution chain rule, it is simple. It is a simple application of chain rule. But in case of differentiation by equation, The chain rule applications involve the algebra of equation. In the following sections, we will describe both such cases. Differentiation of certain function seems to be very difficult, but suitably substituting the independent variable with some trigonometric functions or other functions that can be differentiated easily. This method is called differentiation by substitution. So, if your fx function involves inverse trigonometric functions of algebraic functions, the following substitutions simplify the function fx to be differentiated. Number 1, if fx has the terms like under root a square plus a square, then we have to put the value of x is that is equal to a sin theta or a cos theta. If the function fx has the term like under root a square minus x square, then we have to put the value of x that is equal to a tan theta minus or a cot theta. Condition third, if the function fx has the terms like under root x square minus a square, then we can put the value of x as a sec theta or a cosec theta. If the function fx has the terms like under root a minus x and under root a plus x, then we put the value of x that is equal to a cos 2 theta. Number 5, if the function fx has a term like under root a square minus x square and under root a square plus x square, then in place of x square we have to put a square cos 2 theta. So these are the some values of the x and the function fx that he look like, and then we have to put the value of x that is described in this table. So now we will solve a simple question that is based on this topic. So suppose you have given fx is equal to tan inverse in bracket 1 plus x square upon 1 minus x square. So in that case we have to put x is equal to tan theta. So we take this bracket term 1 plus x square upon 1 minus x square. So when we put the value of x as tan theta, so 1 plus x square means tan square theta. Similarly, in the denominator 1 minus x square means 1 minus tan square theta. So this is the formula of tan 2 theta. So tan 2 theta is equal to 1 plus tan square theta divided by 1 minus tan square theta. So now we put this value here. So fx is equal to tan inverse, and we have simplified this bracket, and that is tan 2 theta. From tan inverse to this tan is cancelled, only 2 theta is remaining. So we write 2 theta. When x is equal to tan theta, then theta is equal to tan inverse x. Okay. So in place of this theta, we write this 2, and in place theta we write tan inverse x. Now we differentiate this function fx very easily. and this function differentiation of this function fx is f dash x, and this 2, and differentiation of tan inverse x is 1 upon 1 plus x square. So that is 1 upon 1 plus x square. So this is the final answer of this question. Now we will see the next question of this topic. So suppose we have given y is equal to tan inverse 1 plus x upon 1 minus x, and we have to find the y dash. Y dash means differentiation of y. So in this question we put x is equal to tan theta. So we take this bracket term here, 1 plus x upon 1 minus x. So in place of x we write tan theta, 1 plus tan theta upon 1 minus tan theta. And this is the formula of tan pi by 4 plus theta. This is the formula of tan pi by 4 plus theta. Now we write the question that is given in question. Y is equal to tan inverse. So tan inverse this. So this bracket we have already solved, and this is the answer. This. So from this tan inverse, this tan is cancelled. Only pi by 4 plus theta is remaining. So in place of theta, we can write tan inverse x. Now your function y becomes pi by 4 plus tan inverse x. Now we differentiate this y, so it becomes y dash, and pi is a constant, and the differentiation of this constant is 0, and only the tan inverse x is remaining. The differentiation of tan inverse x is 1 upon 1 plus x square. So this is the final answer of your question. So now we will move to next question. So if we have given the fx is equal to cos inverse 4x to the power 3 minus 3x, and we have to find the f dash x. So we put x is equal to cos theta. So we take the term which is given in the bracket. So 4x cube minus 3x. So in place of x we write cos theta. So here the power is 3. So it is cos cube theta minus 3x. So in place of x we write cos theta. So this is the formula of cos 3 theta. So now we write the question fx is equal to cos inverse. So in place of this we write cos 3 theta. From cos inverse, this cos is cancelled, only 3 theta will be remain. When x is equal to cos theta, then theta is equal to cos inverse x. Okay. So in place of this theta, we write cos inverse x. Now we will do the differentiation of this fx, that is f dash x. We write this 3 here, and differentiation of cos inverse x is minus 1 upon under root 1 minus x square. This 3 is multiplied to this minus 1, and this becomes minus 3 upon under root 1 minus x square. This is the final answer of this question. So here some assignment problem is given to you, and you have to solve these questions. And so this is question number 1, and this is question number 2. Now the learning outcome. So after this lecture, you are aware about the differentiation by substitution method that will be helpful in solving the complex problem of differentiation. And these are the some reference books from where the learning materials is taken, and you can use these books for your study. So thank you so much.